Hello friends again. I hope you're all doing fine and in a good health condition. Today we are starting with a new chapter, that's chapter 2. That means we are already done with chapter 1. I hope you've learned lots of things from chapter 1, basics of functions, properties, parallelity, perpendicularity of those functions, and lots more. We studied a lot of things about functions. The most important things that we studied in chapter 1, it was talking about slope. Slope is important also in here in this chapter, because there are conceptions and notions that are related to those things that we have already studied in chapter 1. So in that chapter we are generally talking about the derivatives. Okay, chapter 2, it's in general talking about derivatives. You're already familiar with derivatives. In general, if you want to take the derivative of a function, the procedure is called differentiation. Okay, so when we say differentiate the function or take the derivative of the function, it gives the same meaning. There is no difference between differentiation and taking the derivative of a function. The first section that we have got in general of this chapter, it is talking about the notions where the derivatives have come from, what does it mean in general. When we are talking about the applications of those derivatives, what do we mean? So the very first thing that we have got, I will go back to chapter 1 when we were talking about slope. Okay, as I told you, there is a relation between slope and the derivative that we will be studying in that chapter. In chapter 1, when we were talking about linear functions, a linear function, we said it's a function that changes at a constant rate. Let me write it here, that changes at a constant rate. That means the function was increasing or decreasing steadily. We had a constant rate. The function was depending on that constant rate to be increased or decreased, rise or fall. When we had a linear function, when we were talking about the slope of a function in general, the way of writing a function was like y equal to mx plus b. We were calling that m the slope. Okay, and we had an example about that slope, that m, when it was saying that the price of a bottle of soda was changing at a constant rate. We said that constant rate, since we are talking about constant rate, that was the slope of the function. Okay, so what have we studied in chapter 1? We have studied linear functions. Okay, in general we were talking about linear functions. What were linear functions? We said those functions that are changing at a constant rate, or in general we can say that when we have got the x, the power of the x that's equal to 1, we say that those functions are linear functions. So that y equal to mx plus b, whatever function is that, it is written like that, and m is the constant rate that we have got. Okay, that's the slope for linear functions. Okay, the slope was the number that was multiplied to the x. How about if I have got a nonlinear function? Okay, look at the relation between the first chapter, linear functions, and the second chapter. The first chapter we had linear functions. M is a constant rate, was the slope of the function. We could easily find the slope of that function because it was a straight line. How about if you have got a nonlinear function? Okay, that one is nonlinear. Doesn't matter if it is x squared, x to the power of 3, or e logarithm. We have got a curve like that. How do we find the slope of that function? For example, if I'm given y is equal to 3x squared plus 5, I cannot say that that 3 is a constant, is the constant rate. That is not equal to m. Okay, when I say constant rate, that means m, the slope of the function. Okay, I can never say that the number that's multiplied to x squared is the slope. Why? Because that's not a linear function. In linear functions we were saying that this is the slope, but in nonlinear we cannot describe it like that. So how do we describe a slope for how do we describe slope for a nonlinear function? We say that we can find the slope of a curve at a given point By using derivatives. Okay, so how do we find slope when we have got nonlinear functions? We are by using derivatives. Okay, how do we do that? For example, if I want to find the slope of that curve at that point, okay, the point must be described for you, or you have to find it in general. Okay, how do you find that one? We say that the slope of that curve at that given point is equal to the slope of the tangent line. Okay, what's the tangent line? That's a line passing through a point of a curve, or we can say that tangent lines are those lines that are touching the curve at a point. These are just touching, they are not passing through. Okay, that's a tangent line. Okay, that's tangent line. راس تهالي اللي كوتي بيدالين بكردي. That's a tangent line. If you want to find the slope of that curve at that point, we are drawing a tangent line in that point, from that point. Okay, finding the slope of that tangent line will give us the slope of the curve at that given point. Okay, let me write it here for you. Slope of tangent line is equal to what? Is equal to slope of the curve at the given point. Okay, so what's the difference between this one and that one? In general here, we were saying m is the slope for that straight line. For every point on that line, the slope was equal to that m. But when we have got a curve, the slope changes. Why? Because it's depending on the point that is given to me. If the point is given to me here, that tangent line, the slope of that tangent line would definitely be different from the slope of that tangent line. Okay, so if I have got a tangent line here, look, the slope is different. How about if I have got something here? Okay, if it's required from you to find the slope of that curve at that point, look, the tangent line is nearly vertical. Tangent line at that point is different. At that point, at every point on that curve, tangent line is different, so it has got different slopes at different points. Okay, so when it's required from you to find the slope of a curve at a given point, we are finding the slope of the tangent line. Okay, that are the concepts, that are the difference, and what we are looking for. We have got in the first chapter linear functions. In the second chapter, we are talking about finding slope of nonlinear functions, in which we are using derivatives. When we say that find the slope of that curve at that point, at that given point, that means we are finding slope. Okay, so that is equal to the derivative of the function at the given point. Okay, so far what do we know? We know that we are using derivatives for finding slope. Okay, slope of the tangent line is equal to slope of the curve at that given point. And how do we find that slope? Using derivative of the function at that given point. That means we are finding the slope, the derivative of the function. We are putting the point, the given point that's required from us, into the derivative, and that will give us the slope of that function at that given point. Okay, we have got another concept or another notion in that chapter, in that section. It is called the rate of change. Okay, rate of change. You are already familiar with the concept of rate of change. We have studied the rate of change in the first chapter. When we were saying rate of change of a function or anything, that means the slope of the function. Okay, so if it is required from you, we have got three things here. Okay, let me write it for you. Slope, okay, derivative, and rate of change. What is the difference between those three? Nothing at all. Why? Because if it is required from you to find the slope of that curve at that point, that means I'm finding the derivative of that function at that point. That means that I am finding the rate of change of that function at that point. So those three notions give you the same meaning. Whenever it is required from you to find slope derivative, rate of change, these are the same meanings that you are doing the same procedure for finding the solution of those things. That is all about section 1. The important thing here is that you know the difference between linear functions and nonlinear functions, how to find slope in linear functions and nonlinear functions, and you have to know that those 3 terms give you the same meaning. Finding slope is the same as finding the derivative of the function at that point, and it is the same thing as the rate of change at that given point. For finding the derivatives of those functions, we will move to the other sections that will give us rules and methods for finding those kinds of derivatives. We have got also one more point, sorry for that. We talked about continuity in chapter 1, the last section. Here we have got a general idea about the relation between derivatives and continuity. We say that every differentiable function at C, okay, we have got a function and it is differentiable at a point C. What does that mean at point C? That means we can take the derivative of that function and put C inside it without getting undefined, is continuous. Okay, every differentiable function at C is continuous. So whenever you see a function is differentiable, that means you can take the derivative of that function. That means it is definitely continuous without even mentioning the conditions of continuity. You can directly say that that function is continuous. Okay, that's all for section 1. Remember those 3 notions and the difference between those 2. We will move to section 2.2.